Hello everyone. So today I am going to cover some very important topics from enzyme kinetics or enzyme phenomena that is very important for your GPAT as well as specially for NIPER joint entrance examination. And if you are appearing for GATE biotechnology or GATE life science paper, then too you need this topic to be covered very well. Okay, so let's learn this. So actually enzyme is actually proteinaceous in nature in the most cases. Exception is like ribozyme, that is RNA in structural properties. It is RNA but acts as a enzyme, so that is the ribozyme. Okay, so proteinaceous structure, that means primary structure, secondary structure, tertiary structure and quaternary structure will be there. So usually the enzyme functional properties or whatever and any other properties, any other proteins as well, when it we say like functional activity or functional stage or functional state, then it is obviously the quaternary shape or quaternary structure. Okay, so protein. So now come to the enzyme. So now enzyme is also a type of protein. So it has some active site where the substrate binds. Why the binding occurs? It is just because the similarity or affinity of the active site and the substrate molecule. So substrate molecule has affinity to bind the active site, because there is a feelings of or likeness. Okay, so that's why affinity is the responsible for binding of substrate at the active site of enzyme. Okay, so enzyme substrate, when complex is formed, enzyme substrate complex formation is reversible. Okay, after that enzyme substrate complex gets converted to enzyme plus product, that is irreversible reaction or irreversible step. Okay, so see, there is specifically a speed of the reaction, how fast is it happening. So the highest the velocity, that is known as Vmax, so maximum velocity of the reaction. And we have plotted here on the graph, you can see substrate concentration on the x-axis. So x-axis is denoting substrate concentration. As we increase the substrate concentration, the velocity is increasing gradually. Okay, but after a time the change of concentration is not dealing with much change in the velocity. After that saturation occurs, means all the enzymes are actually utilized by the substrate to bind, and now further increasing the substrate concentration will not change the velocity of the reaction. That's why the last part you get. Okay, so now another concept is there. So substrate concentration, as we increase the substrate concentration, the velocity of the reaction is increasing. But when the substrate concentration is km is actually Michaelis-Menten constant. Okay, so Michaelis-Menten constant, at the time of Michaelis-Menten constant, the substrate concentration leads to the velocity of the reaction half of the maximum velocity. Means when the substrate concentration, when the velocity is half of the maximum velocity, at that time the concentration of substrate is known as km. Okay, so km is actually the concentration of substrate at which the velocity of the reaction is half of the maximum velocity. Okay, so Michaelis-Menten constant is very important. So now you can imagine, if we compare two reaction, okay, so more the affinity towards the enzyme and towards the enzyme of substrate, lesser is the km value, means lesser concentration of the substrate is enough for getting the half of the maximum velocity of reaction. Okay, so similarly, if we have km much higher, then it indicates the affinity between active site of enzyme and the substrate is very less. That's why much more concentration of the substrate is needed to get the half of the maximum velocity of the reaction. Okay, so this is the normal graph. So now we will go for this graph. So here what happens, inhibition happens. Sometimes enzyme gets inhibited by some foreign particle or molecule or some elements. Okay, so this inhibition could be three types: competitive inhibition, non-competitive inhibition, and another is uncompetitive inhibition. So first of all, this competitive inhibition. So in case of competitive inhibition, this foreign particle competes with the substrate to bind at the active site. So what happens, when enzyme is free, the active site is free, substrate tries to bind that at that location, as well as the foreign particle also tries to bind at that location. So competition occurs, that's why it is competitive inhibition. So in case of competitive inhibition, if we increase the substrate concentration, it can lower the binding of foreign particle at the active site. Okay, so what happens, in absence of foreign particle, in absence of foreign particle, the concentration of substrate needed for a specific velocity of the reaction is actually lower than the substrate concentration needed for same velocity in presence of competitive inhibitor. Okay, so that's why you can compare the normal graph, that is black one, and competitive inhibitor, that is red colored. In case of competitive inhibitor, Km got increased, means the half of the velocity. To get the half of the velocity, maximum velocity of the reaction, we need much more substrate concentration than absence of substrate concentration, absence of foreign particle, means inhibitor. But see, one thing happens, as we increase the substrate concentration, the velocity increases, but after a limit it does not get increased. Okay, so that is actually because of saturation. All enzymes are bound with substrate or inhibitor. Okay, so that is the saturation. So in case of competitive inhibition, Vmax does not get change. Okay, but Km get increased. We need to remember this. In case of non-competitive inhibition, the inhibitor binds to other place other than active site. So in this case, the Km does not change, but the Vmax get changed. Vmax get lowered because the maximum velocity could not be achieved due to blockade of some enzyme by inhibitor. But in case of uncompetitive inhibition, Km is increased, but the Vmax is decreased. In case of uncompetitive inhibition. So in case of uncompetitive inhibition, Km is increased, means affinity, means the substrate concentration needed for the half of the velocity is increased, because some enzyme got blocked by enzyme substrate complex bound with inhibitor, and Vmax is decreased. Okay, so thank you all, study well, all the best.